So often when we do a reaction in lab, we use something called percent yield to kind of gauge how well the reaction went. So percent yield is used to determine the percentage of product produced compared to how much product you should have produced. So we're comparing what we actually get to what we should have gotten if the reaction went perfectly. And there's a simple equation that we're going to use for this. And so it's actual yield divided by theoretical yield times 100. So your actual yield would be a number that you get from lab. So this would be, say, your mass from lab. Those are your results. So in a question, if it says you actually produce this much product, that's your actual yield. Theoretical yield is how much you should have gotten, and that's from stoichiometry. So that's where you use the mole ratios, convert from grams to moles, use the ratio to figure out how many moles of product you should have made, and then convert that back to grams. So it's important to know that these two units have to be the same. So you can do percent yield with moles, or you can do percent yield with grams. It works either way because it's really just a percentage. But they have to be the same. So you still have to compare moles to moles or grams to grams. But our actual is what we're really producing. Our theoretical is what we should have produced. And then to turn it into a percentage, you multiply by 100. So that's a pretty straightforward equation. So let's actually apply it and do a practice problem. Okay, so our first problem says, in the lab you react 3.5 grams of copper 2 chloride with excess iron. So we did this in class. We massed out our copper 2 chloride. We have lots of extra iron. And so we're going to react those two, and we produce copper and iron 2 chloride. So there's two parts to this question. The first question is how much copper should be produced? This is our theoretical yield. So to find our theoretical yield, we're going to use our mass of copper 2 chloride, convert it to moles, and then do the mole ratio between copper 2 chloride and copper to figure out how much copper we should have produced. Okay, so I'm going to start by taking 3.5 grams of copper 2 chloride and converting it to moles, which means I'm going to divide by the molar mass. So I need my calculator and my periodic table. So I'm going to add copper, which is 63.546, plus 2 chlorines, which is 35.453. And I get a molar mass of 134.452 grams. So when I do 3.5 divided by 134.452, I get 0.026 moles of copper 2 chloride. So that's what I started with. And so now I have to find my mole ratio to go from copper 2 chloride to copper. So if I have 0.026 moles of copper 2 chloride, to find my mole ratio, I'm going to go to my periodic table. So I see for every 1 copper 2 chloride, I get 1 copper. This is a balanced reaction, and so it's a 1-to-1 ratio. So I get 1 mole of copper. So if I start with 0.026 moles of copper 2 chloride, I should end with 0.026 moles of copper. And now, to put this in a little bit more practical unit, we're going to convert this into grams. So 0.026 moles of copper. And then I know for every 1 mole of copper, I have, off my periodic table, 63.546 grams of copper. So if I do 0.026 times 63.546, I get 1.65 grams of copper. So that's what I should get. If the reaction went perfectly, I should produce 1.65 grams of copper. So this is my theoretical yield. Now, the second part to this question says, if you produce 1.35 grams of copper, what is your percent yield? So this number right here, my 1.35, is my actual yield. because it says if you produce. So that's how much we actually made. So that's what we would have massed in lab. So I'm going to do actual divided by theoretical times 100. So I'm going to do my actual, which is 1.35 grams, divided by my theoretical, which is 1.65 grams, times 100. Oops. And I get an 81.8% yield. So that means I made about 82% of the product that I should have made. Now, there are several different reasons why we may not have gotten exactly 100%, and let's talk about that next. So our percent yields can fall into three categories. We can have a percent yield that's greater than 100, we can have a percent yield that's exactly 100, or we can have a percent yield less than 100. So let's talk about if it's equal to exactly 100%. So if your percent yield is equal to exactly 100%, that means the reaction was perfect. It means you didn't gain anything, you didn't lose anything, you made exactly the right amount of product that your reaction, your stoichiometry predicts you should have made. So that's what happens if your percent yield is equal to 100%. If your percent yield is less than 100%, that means somewhere you didn't make as much product as you should have. And there are several different reasons why you may not have made enough product. Maybe you didn't let the reaction happen long enough. Maybe you still have reactants left that didn't turn into products. That would decrease the amount of product that you made. Maybe it was something that you were actually doing in lab, say decanting, and you lost some of your product. There are lots of different reasons why the amount that you measure could be less than what you actually got. And so it's usually somewhere tied to an error in lab. And it could be an error you could avoid, and it could be an error that you couldn't avoid. There are some things that we just can't avoid doing in lab. For instance, in our lab when we're decanting, we can't avoid losing a small amount of the product. It's gonna happen. Let's talk about if our percent yield is greater than 100. So if your percent yield is bigger than 100%, that means you gained extra product somewhere. So in this case, you made more product than you should have. And there are also several reasons why this might happen. It might happen if there's some sort of contaminant. Maybe if you're massing a product and your product's not completely dry, you're including some water in that mass. So your mass is going to be higher. It's going to look like you have more product than you actually do. Maybe you accidentally spilled something into your product. When you were cleaning, rinsing, doing something in lab, you might have inadvertently added some other compound to your product, which would again make the mass seem higher than it originally should have. You should not get a you should not get a percent yield greater than 100% because that would violate our law of conservation of mass. That means we would make more mass than we should have made in our reaction. It happens sometimes though. Again, it's an error. So we can use our percent yield to kind of determine how close to perfect our reaction was. Maybe we added something extra we shouldn't have, maybe we didn't let something go long enough, or we lost some of our product. So that's kind of how we interpret our percent yields.